All right, so I was looking through what we went over last time, and I also wanted to see how you guys did on assignment 01 um, and the first one as well, because I wanted to see how well did you copy code that you saw. Did you understand the workflow that Professor Steady was going through? And then in regards to the one, I wanted to see how did you take the information I gave you guys from the video and then those other subsequent videos as well that were from the study. How did you gather that information that was given to you, in 1 day and 2.5 hours, and then what did you do with that? Were you able to take that and be able to produce code? That was what I wanted from that, and honestly, majority good results, really good results. There were very few people that didn't. I'm not going to say didn't attempt. I'll say did not submit Project 01 for the triangle calculator. And there were some that did not do the working demo one correctly. And it was because of how things were copied. And we'll look more of why that happened later as well. So again, just a reminder, thanks for the student that pointed us out. There is a textbook that is recommended for you all to use. And again, it's free to you and it's been given to you freely. And I will always provide the links for it. I mentioned last week that I will even tell you where to, I will keep adding it to the weeks when it's important to go back and review stuff or to look at something. So I did that. In the beginning of week 2, you'll see this, read chapters 1 through 3 of this book. And that should kind of further solidify things that we have gone over. But practice is always best, in my opinion. So even when you're going through this book and you see examples, I say open up idle shell, give it a try there, and then also open up your own file, a new file, and do it there as well. One other thing with the homeworks, when you submit the homework, you don't have to submit like an image of the idle shell, like showing me what happened in that. You don't have to submit. You don't have to save the idle shell as a PY and submit that either. I don't need to see you running the code and showing me that it worked on your computer. I need to see the code myself because I can run it on my machine. And those that did that, I completely understand. This is your first time. And again, with the homeworks, I think I mentioned before that you're allowed to make corrections, and I will always make comments, and hopefully I get everything within that comment so that you can see where you can make those corrections, because I don't want you all on your own, or this is your first time. Some of you, it's your first time ever programming. I don't want you to feel like you have to be perfect at it from 2.5 hours looking over something. That wouldn't make sense, and no one would ever imagine you could do that in the real world either. So, all right. But before I move forward, I am going to review over some things again based off the most common errors I saw with the 2 homeworks. But before I do that, are there any pressing questions that anyone has? Be about anything in regards to Python in this course? No? No one? Okay. I will ask that if you aren't speaking at the moment, if you could mute yourself as well, just so we don't get any feedback. All right. We got almost everyone. So I'm going to mute those of you that haven't, if it lets me this time. All right. And then if you need to talk, feel free to speak up and unmute yourself. Just make sure you're unmute when you talk or use the chat. I think I got all the feedback rid of. Looks like I did. Okay, cool. I don't hear it anymore. All right, great. So what I wanted to start off with was going back through, oops, there it is. Going back through the program development cycle. And if this lets me share with you guys. There we go. right, can everyone see that?
I'm only seeing the canvas screen.
Okay, good. Yes, there should be a white space. So you guys do see the white space? That is good. All right. There's a reason why I'm going to that. Because we're going to talk about the programming development life cycle again. And I want to make sure that this is solidified because that was the whole point of the workflow demo. And this will be very helpful with your triangle calculator and with anytime you code. I mentioned before, and I'll continue to mention over and over in class because I know that this is something that continues to come up. But when people program, the first thing that they tend to do is go straight to code. That's it. They don't think about anything else. So for instance, when I gave you guys the triangle calculator assignment, many of you went straight to, all right, well, I need to get this user input and then I need to do these calculations and go. And then a lot of the questions I got over last week were in regards to, hey, this isn't working. Well, it is always working as what's given to it, because it's just the computer. It's doing exactly what you tell it to. Maybe it's not working as you intended, but it is working. And so sometimes if you see an error come up, you can always read it and kind of it will give you a hint of what it sees as wrong, and you can use that to kind of backtrack. But also, if it say it just runs completely, but you don't see what you intended, well, there's a reason why that's happening. So I wanted to use the triangle calculator as an example to go through the programming development cycle. Is mine connected? Okay, cool. So you got that working on the side. All right. So let's talk about the program development cycle. So first thing first, we are to understand the problem. So if I were to go back to just say the triangle calculator, and I read through the assignment. In this assignment, you will write a Python 3 program to calculate the length of the hypotenuse, side C, of a right triangle, given the lengths of the other two sides as provided by the user. The program will also calculate the area of the triangle and the perimeter, which is the sum of the three sides. Okay, so there are other specifications with that, but the problem itself is to write a program that calculates the length of the hypotenuse of a right triangle, given the other two sides provided by the user. The program will also calculate the area of the triangle and the perimeter. All right, so first things first, the problem, I've said it a couple of times. I understand what I need to do. I need to take information the user gives me and calculate the hypotenuse, the area, and the perimeter. So that's exactly what I would say. I would probably write that out even myself.
Professor, we can't see the screen.
Do you see a 1?
Light screen.
Yeah, there's a 1 in the upper left corner.
Okay, good. All right. Yeah. So yeah, I took the screen away because I'm using a whiteboard to kind of write out the program development cycle. Sorry about that. So the problem is that we are trying to calculate the hypotenuse, area, and perimeter given user input. So actually, I'll write that out first. So what's the problem? Okay, there we go. All right, looks like I am going to have to probably switch back to just typing on the screen. So it's like my pen's dying, but let's see. There we go. That's somewhat better. Problem. All right, yeah, I'm gonna switch back. Sorry, everyone. Looks like my pen is dying. So log out of that. And let's go back to I apologize about that. That looks like that didn't work out how I planned, but that's okay. So I'm just gonna do it in a Google Doc. Huh. I'm just gonna make a generic one just so you guys can at least see what I'm talking about as we go forward. So first things first, we have a problem. Okay, well, what's the problem? The problem was that we need to take user input and calculate hypotenuse area and the perimeter. Okay, so that's what we need to do, plain and simple. All right, so well, the next thing we need to do is to plan it out. Well, how would you plan it out? So what would you need to do in order to solve this problem? Anyone have an idea of where you should start? We know what we need to do overall, but where should you start then if you're planning this out? I know some of you finished this too, so I know that you have some idea of what to do. And I'm not asking code, I'm just saying in words, what should you do?
I want my son to know that I try my best to make things better for his generation.
Is Showboard?
Scranton is a long way from Wall Street. You won't find skyscrapers.
Knowing the formulas for what they're asking, all right, that might be a great place to start off. Knowing the formulas, okay. Are you saying we want me to show the board, or are you talking about drawing the show board, Kanash? Drawing, okay, good, yeah. Knowing what, knowing the formulas for what is asked, you could draw it out on a board. And that's kind of what we're doing here. We're drawing it out on a board. What are other things that you would do? And we'll probably reorganize this list in a moment because we're planning it, right? But what are the things that we need to do within this? So understanding what the formulas that we actually need are, that's great. And I said drawing out a board, creating variables, okay? We're gonna need to create variables for the hypotenuse, for the variable for area, and variable for perimeter. Okay, and we may need those, we may not, but those are good things to have. All right, so what are some import math? Okay, so Rod mentioned in the plan, he's saying we're probably going to need to import math. Is there a reason why you think we should import math, Rod? It won't necessarily hurt, but I'm just wondering if there's any particular reason. The formula's already set. Okay, it already has the formula's already set for what we're doing. All right. Okay. All right. So we almost started talking about like some coding things, but what else just period? So imagine that you had no computer to do this. And I told you that a user, so myself, was going to give you two sides, and I needed you to calculate the hypotenuse, the area, and perimeter. If you have no computer, how would you do this? So you guys already talked about knowing the formulas for what it's asked for. Okay. All right. So yes, you would measure the sides. So you would have to So I will give you the measurements, but you're gonna have to take the measurements from the user. All right. So someone else mentioned testing it with a set of numbers. That will also be good. We're gonna have to test it at some point. Okay. All right. So I'm gonna kind of rearrange some of this. So where would we probably start with this? So the first thing that we probably need to do out of these, anyone got an idea? We got A through H. What should go first? E, take measurements from the user. Okay, couple of G's. A, know the formulas we're asked for. All right, so I'm gonna actually go with something that someone mentioned earlier. I'm gonna draw it out on the board first. But actually, before I draw it on the board, I need to know what I'm drawing. So let's do G, like you guys said. Let's take the measurements from the user. All right, so take the measures from the user. Now we can draw it out on the board. All right, which this case you won't be drawing it necessarily on the screen because you guys don't know how to do that yet, but that is something that you could do, and it probably, regardless, it'll be helpful for you when testing it out. So that was part of the reason why I wanted to use the pen, so you guys could see me actually drawing it out. But now that we got that, take the measures from the user, draw it out on the board. Well, what else are we going to do once we have done that? Once you've kind of drawn it out, someone mentioned knowing the formulas, what is asked. That's good. That probably should go next, right? We have to know what formulas we actually need to use. For instance, as someone mentioned earlier, import math has a lot of formulas built in. I said we may or may not need those, which is true. So we need to know what formulas we have to use next, okay? All right, so once we know what formulas they're already using, I'm gonna add another level here. Well, what formulas do we need to know? What are these formulas? Or how could you find them? Anyone got any ideas? And feel free to unmute yourself to speak if you want. Okay, it was given in the instructions, but yes, I like what someone said. You could Google the formula for hypotenuse. Yes, so we need to know the formula for hypotenuse. In this case, as someone else mentioned, it was given in the instructions, but we need to know the formula for hypotenuse. What else? We need to know the formula for area. Good. And perimeter. Good. Those are all the formulas we need. And some of you are going as far as to actually start listening to formula to me privately and to everyone. So for hypotenuse, we know the formula. We need to take the square root of side A squared plus side B squared. Okay. Someone else put in perimeter. Perimeter was the sum of all the sides. That's great. Sum of all sides. Let's just say we didn't know what that meant. Well, you look it up even further and you see that you need to just do side A plus side B plus side C. Okay, good. Okay. Well, let me before we move to the area, let me ask you this: if I gave you the formula side A plus side B plus side C, would you guys know what side C is based on how we've planned things out yet so far? All right. Someone said it's the hypotenuse, which is correct. Good. All right, and then area. You can Google that too. And I actually saw two different ways that people found area. Generally, people did a lot of different calculations to get those. But yes, we can do base times height divided by 2. But again, you guys know what the base and height are based off of our plan. Where are the base and height going to come from? Good. A and B. Good. So side A times side B divided by 2. That is not the only way to find area. There's another way. It's called Hero's formula, which someone did use. I'm gonna put a side note. Oops. Could use Hero's formula. Find area. That involves using all 3 sides. So, which that was, I made a comment on the person that did that. That was very clever, and it could be used for any triangle, not just a right triangle. So that is great. But anyway, back to problem at hand. This seems pretty good, right? If I actually were to give this instructions to probably a middle school student, would be more efficient at this because they would at least hopefully know how to do exponents, right? But if I gave this to them and say, hey, you're gonna take the measurements from the user, you're gonna draw this out on the board, then you're gonna know the formulas that are gonna be asked for, and here are the formulas for you. The hypotenuse is take the square root of side A squared plus side B squared. The area will be take the side A times side B and then divide by 2. The perimeter is side A plus side B plus the hypotenuse you already calculated. They'd probably be able to do it, right? Yeah. So, and these other things we had, like I said, most of this was involved more with code, but it is a part of the plan. As one of you pointed out, we may need import math to handle some of this, right? I showed you guys that square root is not a function that's already built into Python unless you do it to the power of 1/2. So you would have to use import math for that. There are some other functions within this as well. So I wanted to for you guys to take a look at that actually. So I'm gonna go to one of my other tabs here. For those of you that don't know or that have never shared a screen on WebEx, sometimes when I try to go to these tabs, the screen share menu pops up over it, so I can't get to it. So, oh well, I guess I can't show you guys that. Oh wait, if you're ever working in Chrome, and actually I think all of them do it now, but if you want to move through multiple tabs, what you can do is I know I need to get to the 3rd tab, so I can hold Control and hit 3, and it'll switch for me. So if I want to go back to the 1st tab, I can hit Control and 1, and it'll go back. So that's just showing you guys something on the side that's very helpful. But this is the documentation directly from Python in regards to the latest version, 3.85, which is the one that we all downloaded last week. And here are a bunch of functions that are built into it. So it has ceiling, combinations, factorials, floor function. I mentioned ceiling and floor last week. Some of you may know what a factorial is. Float sum, GCD, some of these you may have heard from, or you maybe have your kits of your own, and they may need to do some greatest common divisors. This is where you could do that. But yeah, there are tons and tons of different functions. Look, I'm just scrolling around logarithms, trigonometric functions. There's a hypotenuse function there, actually. Sine, tangent. Some of you may be able to use this in some of your other classes as well. But that's the math one. There's another subsidiary math, which is called CMath, and it's for complex numbers. So if you're ever dealing with complex numbers, you could use that as well. So you can do your math homework in Python. But here's all these different functions in here. And sometimes we don't need all of that because whenever you import, we're getting all of that. So, but as it was mentioned, we may end up needing to actually import this stuff early on in because we may use some of it. I'm just gonna put that up here. And whenever we create these variables, they're gonna be for these items, right? So I'm gonna put you here actually. I'll put this above that or right in front of it. Create variable for hypotenuse. And do that. And same thing for these guys. You need to format as well. Ah, yes, we will need to format as well. Because once we get these values, we have them. Great. We tested. We tested it. We actually can't see if it works, right? Why not? Why can't we see if it works from now? Someone mentioned that we need to format. Well, what do you format? Do you just format anything? What type of values do they need to be? Oops. So you mentioned formatting. Say 2 decimal points. Format results to 2 decimal points. Good. Which are floating values. Yes. I'll put that in parentheses, floats. So that's important too. Because I like what some of you all did. Whenever you took the information from the user, you automatically made them float. Did you have to do that? No, they need to be float points at the end at least. Some of you just straight up in your thing said enter a positive integer or enter a positive whole number. That straight tells me I only should be entering a positive number in this because you're expecting it to become an int. But some of you left it flexible so that the user could input a decimal number if they wanted to. Did the instructions say that they had to allow that to happen? No. But I'm glad you did, because it's a lot. Some of you are thinking further ahead about how it might be used, and neither one is wrong. You were given instructions. That part was up to you to interpret. Did you want it to be an int? In the examples I gave in class, I did an integer when I took user input. But so when we take the measurements from the user, they could be ints or they could be floats. We'll decide which one is probably going to be best for us. Okay, cool. So we need to format them at the end. All right, I think this is a good plan, honestly, right now. And so now that we have a plan, now we can code. This is where you begin to code. And some people even go as far as to start doing what's known as pseudocode. And what that is you mix coding language and English to kind of go through what you're doing, which we've kind of done a little bit up here, right? But instead, I'm going to go to Python now to do this. And if you guys, just in case some of you forgot, I'll go back my start menu here. And if I go down to my P's, there's Python. Yay. And we're opening idle, not the other one. This will kind of open up a command window. We want to open up idle so that we can work directly with the integrated environment. So, and you know what? This class is happening every Monday, and I use Python a lot on this computer, so I'm going to pin it here so I don't have to even open it up every week. If I wanted to, I could have that be a shortcut, but I prefer pins on the taskbar. So now I got that, I'm going to go open up Python, and you all should be able to see my Python shell. Everyone see my shell? Good, good. All right. So from my shell, I can, okay, so somebody doesn't see it. Make sure that I'm completely sharing. So I am sharing the entire window. Rod, do you see it now? Yes. Okay, good. All right. So at this point, I can start coding away. I'm gonna try to have both screens up at the same time so we can kind of see what I need to do as part of my plan and at the same time code. So I can start coding directly in the shell, right? Anyone have a problem with me coding within the shell? Well, I do. Remember I said you want to do this on a new file. Now, could you actually, yes, it won't be saved, good. So at this point out, it will not be saved if you just type it in the, if you just do it in the shell. Now you can take the shell and then save the stuff that's there, but it will come out in all caps. And I won't be able to, well, I could run it, but I'm not going to because it won't run the way that you are expecting it to. So what I'm going to do instead is I'm going to go to File and go to New File. Notice it has Control N. Those should probably be staples to you for when you open up like a new window or you're creating a new doc in Word or something. And this is what I'm going to work with, and the shell is where we're going to run things, okay? So I have my new Python file created right here, and this is where we're going to work. So you know what? Something else that I like to do personally when I create my plan is I go over and I take my plan sometimes, and I will do this. Just copy and paste it right there. Well, what's wrong with what I just did? Or tell me why it's good, what I just did. Or how I can make it better. It's acting as code and not as notes. Make it into a comment. You answered all my questions all at once. No hashtags. That's right. That's right. And I'm getting used to saying the word hashtag. I'm gonna stop saying pound. All right. So if I do this here, and in some of your integrate your IDEs or some of your environments, which you can do. Some things that you can do is you can actually like highlight all of this at once, and it'll comment, and then press certain keys, and it'll comment everything at one time. Now, do you guys have an idea of why maybe I go in and I comment this, or I go in and copy my plan in and I comment it out? Anyone got an idea of why that might be a good idea to do sometimes? Good idea to copy your plan directly in your code and comment it out? Oh, all right. Well, stay on track. Yes, it helps you stay on track. All your references are in one place. Future reference. It'll help when testing. All of those are correct. It will help when testing, because say you get an error, you'll see what line it goes to, and you can come back to your code and say, okay, what line is that? Well, this is where I was doing this step. How did I mess up this step? Let me look back at my plan. Oh, it's right there for me. And also, the last part of the programming development cycle is documentation. Only one student documented their work completely. I think there was one other that kind of gave a general description at the top. General description at the top is great, but documenting within your code is even better, because I can clearly see this is what you meant to do at this step. This is what you meant to do at this step. Because you're telling me, and then I can see the code after to see if you really did what you said. So, boom, I'm pretty much almost done. All I got to do now is to put the code in here, all right? So, taking measurements from the user, it can be answer flows. Well, how do we take information or data from the user? Anybody remember what that function was called? So good, that was called input. Okay. So as I was doing that, we do get a screen tip to tell me that input is arguments are a prompt. Does a prompt have to be there? It says equal none. Let me tell you guys a little bit about what that means. So whenever you're creating or using a function, it has arguments. Sometimes it has no arguments, and if it doesn't have any arguments, then it won't have anything there. You'll just open parentheses, close parentheses, and it'll run perfectly fine. But there are some times where you have optional arguments, and when we get to creating functions, this might be something that we do. We tend to not use those a lot in courses, but it might be fun to at least do. So remind me if I don't go over it. But an optional argument is one such as this. You are giving what the argument would be called. It would be called a prompt. If you put an equals and put something afterwards, you're saying if you don't enter anything in, it will automatically put nothing. In this case, it'll be equal none automatically. So if we wanted to, we could totally just do this, right? Cool. Well, I'm going to run it just so you guys can see what happens when we do that. All this 02. You guys can call it what you want. I'm calling it that so I know week by week. This is the stuff I was working with. So, boom, it started. And, oh, well, it looks like it's waiting for me to type something. So I'm going to type in 8 here. Okay, cool. All right, so it took the input. Well, what now? What now? Was that good enough? Was it obvious to you that you needed to type something from that? Probably not, right? So it might be a good idea to enter a prompt. So within here, I'm going to actually enter in my prompt. Yeah. So I'm gonna, as someone pointed out, it might be a good idea to actually request that value. So, hey, user, enter in first side length. Okay, cool. Some of you did some fancy stuff by like putting a colon in at the end, which is great. You do a comma, or you could leave it blank, however you wanted to do it. I think the colon is a nice touch. A lot of you use the exact same wording that was given in the example there. Great. One person, I really love how they did this. They actually put in their own wording, kind of like what I'm doing here. You know, this is your program, this is your code. You know, send it to me how you want. If you want to add in things like, hey, user, or what's up, or whatever, do that, you know. Of course, keep it professional too. But I get a kick out of looking at those. And sometimes your comments I get a kick out of looking at too. They had a joke in one of theirs, so that was kind of fun. But so from this point now, if I were to run this today, my F5 is actually working today. It says, hey, user, enter in your first side length. And I'm like, okay, great. I'm going to enter 8 in. I guess it's working. I mean, it took it. Well, if I go back here, we know it should be more than one measurement, one thing, right? But for 2, it took in that value, but I don't have it going anywhere. And this is where we talked about variables last week, right? Your variables allow you to save data to a point. So that way it knows where it will point back to that value constantly every time that variable is called. So they're very important to use. So I could name this variable Tommy if I want to. And then I can keep working, right? And as I keep using this, I can use Tommy throughout this program. Is Tommy a good name for this variable? And if your name is Tommy, you may think it's a great name. Tommy, as your name, is a great name. But no, it's not a great name for this variable. Anyone have any reasons why that Tommy's not a good name for this variable? Yeah, it doesn't tell us anything. Tommy is completely random, so it throws the user off focus. Yes. It would throw you as the coder off focus too, right? Or let's say you turn this in, I'll be like, why did they put Tommy here? Now, there are times when you'll code and you'll be like, I have no idea what to call this, but I don't want to type a long name for the variable. I've had to do that recently in the code I was writing, and I just put in a comment that I use like the letter T, and T stood for taking control of da-da-da or something. But in this case, it'd probably be better to do like A or side A. That's what we were using, right? In our plan, that's what we called it, side A. Let's just call it side A. I can do side capital A. I could do side underscore A. I could put just an A, capital or lowercase. You can use any of those. Those would make more sense, right, to you as a coder. So, all right, great. So we have more than one of these, so I need to do the second one too, right? So I'm going to be lazy, and it's okay to be lazy. We're programmers. That's why we're programming things to do our jobs faster. So I'm going to do that. But if you ever do this, if you just copy and paste, make sure that you go through it and make sure that it is correct. So we had to enter the first side. Now we're entering in the second side. Now that we got that, we can draw it on the board. In our case, it's already been drawn out, right? We don't, and you guys haven't learned how to necessarily draw anything on the screen yet. So instead, I'm going to import math here. Just like we said in our plan, import math. Now, when you import math, it imports all of those functions as a complete package as I showed you earlier. Now, in this case, you won't see that much of a difference, but if we were to actually do a runtime test to see if it's faster to import all of math or import just a couple of things that we would want to use, which one would be faster? Well, it'd be faster just to import the things we're actually using. So, I think I mentioned it to you guys. I may have actually done it, but I feel like I just mentioned it to you guys. Could you add something to the end of import math to just import squirt? Yes. So that's what we're going to do here. So the way you would do this to import just specific functions, and I'll put this here in quotes because I'm going to put this up online for everyone to see. To import specific functions, use from whatever the module is. In our case, that's math. Import the functions. Okay. And you can get real fancy with that, and I'll show you in a second. But from this case, say we only just want to squirt. I can say from math, import squirt. Okay. And I'm going to jump back to the shell just so you guys can see an example of that being done. So I'm going to say from math, import squirt as R. And I'm going to do R9. I might need to still put math dot. There it is. What? How does it know that R? How does it know that R is the square root function? It's clearly written as SQRT. Well, from tells it to go to this module. Import is telling it what to get. We're getting specifically from this math module just squirt. As allows us to call it whatever we want. Like, how powerful is that? That way we don't have to type out squirt a bunch of times. I chose R because R stood for root in my mind. Probably wasn't the best thing to pick, honestly. Probably a much better things to use. But that worked fine, right? And I can keep doing that all day. I can do R of 81, gives me 9. Do R of 625, and it'll give me 25. Just all day long. And so that's how you do that. Now, did you have to do that? No. You guys could have done import math. You can do from math import squirt if you want to. But this allows you to name it what you want. And that's how you can get around like having to type math.squirt, which again, not too long, but you know, that's 9 characters instead of just in my case 1. So we don't have to do that, but I'll leave it as squirt for now. This is good for you all to understand what squirt is. So now that I've imported, we talked about knowing what formulas were asked, and we have a thing here saying that we need to create our variable, and we have the formula too for hypotenuse. So what I'm going to do, and this again is not the only way, as someone mentioned, there's an actual function in math that will allow you to find the hypotenuse. So I'm going to do HYP. You could type out the whole word hypotenuse. It's up to you as long as it's easy for you to understand. And then like someone coming back in later, like for example, me, when I'm reading your homework, I'm going to look and see, okay, that's a good name for a variable. And I will comment on that. Even if your code works completely fine and you use a bunch of random names, like every member of your family or something. And I have seen that over the years. I've seen a lot of crazy things. I've seen someone go completely through the alphabet A through Z and then start AA and AB and AZ like they were in Excel or something, which is completely fine. It worked fine. But I told them, it might be better to just use some other variables. But anyway, so I'm going to use hype here. And we already said it's the square root, which we already imported up here. I'm actually going to do math on squirt. And then we have the screen tip telling us what to do, but we need side A squared. Side A squared. I'm hoping someone catches this. Side B squared. Okay, and we're good, right? Anyone have any problems with this? No carrots. Yeah. We're not Bugs Bunny. We don't like carrots here. Now, did anyone find out what carrots do in Python? Anyone? Like, I looked it up, but it went way over my, okay. I understand that. All right. Well, I'm gonna leave you guys to do some more things with carrots, or to look up more with that later. So that's something we're really gonna use, but it has to do with the bits. There are a couple other things with. Yep, it is bitwise. Yes. So yeah, it has to do with the bits that are used with it. So how many bits that represents, and you can change it to different bases. So with the number that follows afterwards. So, but in regards to this, okay, yeah. And I may talk about that in the future. That's not something we really need to cover in class, but I just thought it'd be interesting for you guys to look it up, especially because your instinct may be to use caret a lot of the time, especially when you're doing things with exponents. But how do we do exponents? Anybody remember from last week what kind of operation we used to do exponents? Yeah, that's good. I like this. If I gave you guys quizzes like this, would you enjoy that too? No? Okay, no. I got a bunch of no's on the private, so okay. No quizzes. Assignments are better anyway, right? You get to actually jump in. But that's how we can do our exponentiation. We're gonna do our double asterisk. Now, some of you use PAL, math.pal, which works just fine. Math.pal works just fine as well. And it's just takes the power. All right, good. So our first part here is done. Now we need to do a variable for area and then follow its formula. There were two formulas that are possible for it. I'm gonna go straight to doing this one since we already have everything we need to do it. Area is, we said it was gonna be the base times the height, right? So I'm gonna take, in which we further indicated with side A times side B. So I'm gonna do side A times side B divided by 2. And I should have been lazier and copy and pasted that. Sorry for not being lazy enough. But yeah, there we go. And then the last part was the perimeter. So I'm gonna go do that. I'm gonna call it P. I am gonna be lazy here. I'm also gonna copy and paste this guy. So we called it height instead of hypotenuse. All right, cool. I got a lot of stuff done. I'm all done. I'm gonna run it. Woo! 2, 3, 4. Huh? Let's see what happened. Oh, I did the from. That's right. I don't have to do that there. So I'll explain what happened there in a second. 3, 4. And that says a string. Yes, good. That's the error I wanted to get. All right. So the other one, I'll explain anyway. I didn't mean for this to happen, but we did the from import, so I don't have to actually say it's math. When we did import math, I needed to tell you what to grab from it, so that's why I had math.squirt. But now we're telling it what specific function. It knows that we're looking for squirt, so that's no longer needed. And just like up here, I didn't have to do math.r. I could just put r because it already understood that this squirt that we're getting from math is r. All right. But what I did want to show you guys is here we got an error. Let's try to see what this is saying. It says unsupported operand type. Some of these words we might not understand, but that's okay. You guys know what a type is. All right, we talked about types in Python. Can anyone tell me what those 4 types are that we're going to be working with? 4 types, 4 data types. Strings was one, yep. Floats was another. Boolean, good. One more. Strings, floats, booleans, and the last one was integers. Good. All right, so which here it says for the double asterisk or PAL, which we both know are for exponentiation, we should be it's a string and an int. So it's using strings and ints here. What is it talking about? Strings and integers. We got numbers, right? It says that this are strings and integers. Well, the number 2 is clearly an integer. So it must be saying that side A and side B are strings. They're not strings, right? They're numbers. Where do we make a mistake? Well, it says side A and side B are strings. Let's see where side B and side A are invoked, where they're created, where they're first instantiated. They're up here. And the user is entering in numbers. Why does it say these are strings? Anyone have a solution? It actually was up here in our plan. We need to make sure that we cast it to an int and float. The input function, yes, good. Someone put it up here. Int the input. The input function takes in values and then puts it on, casts it as a string automatically, because that's what it returns. It returns a string. So what it gathers from the user, it takes all of that and puts it in as a string. There's a reason for that, because if it sat and tried to figure out, oh, what did they enter an int in? Did they enter a float? Did they enter a Boolean? Or was this just string? It's easier just to say string and then expect for the programmer to tell it what it should be. Okay, right? Because who knows how long it is the thing that is typed in there for the user input. I went kind of crazy on some of you all's homework, and I tried to see how big of a prime number or prime factorization I could get, and I typed in a 12-digit number, and it crashed my computer. So just for fun, just to see what would happen. But that's to show how important it is for it to be cast appropriately, right? Because that actually would have worked if it had been left as a string. It would have given me 0, and I would have been like, that's weird. But yeah, we should do something here. And some of you did int, as I mentioned earlier. Int would work just fine. Float was better only because it allows the user to enter in whatever they want as a number. It could be as a decimal, and it will calculate it that way. If you leave this as an int, even if they enter in a decimal, it will change it to an integer, and that could cause issues later on with your output and what's correctly calculated. So I am going to use float here. You could have used ints, as again you all saw. It worked fine, and it does work fine. I'm going to put a open and close parentheses with that. Does it get mad at me if I don't? I don't think it did. Good. So it does show you when you do that. It shows how it covers the whole way. Some other IDEs will yell at you if you don't put the close there. Someone will automatically put it there for you. So depending on the environment you're working in, which I'm assuming most of you are working in within the Python IDLE that you got when you downloaded it, it will not automatically put it there, but it does highlight to show you that it's fully enclosed. That's very important to keep track of. We used to have this thing where we would count these. So as I type the next one, I'm going to actually demonstrate that. So float, I would count this as a 1. I would go over here to be a 2. I would go back here, and that's a 1 because I've closed off 1. So that means I need another one to get back to 0. You should always be trying to get back to 0. So again, that was, here's one of them. It's 2. This closes off something, so this goes back to 1, and that goes back to 0. You should always be going back to 0. All right, cool. So let's see if my guy crashes now. I'm gonna put 3 here, I'm gonna put 4 here. It didn't crash, but it didn't do what it's supposed to do. Why not? Because again, if it doesn't do what it's supposed to do, it hasn't been programmed to do so, even if you're 100% sure that it has been. Well, what did we not do? It's supposed to calculate the hypotenuse, area, and perimeter. It did do that. I guess we didn't really fully understand the problem because there was something else it needed to do. What did it need to do after it calculated it? Print it out. Yeah. Print out those results. And we already talked about it formatting, but we need to actually print out those results as well. I'll just put print hypotenuse, area, perimeter. And I'll put all that here. So I'm going to add that in to my comments for my documentation. Okay, so that's the last thing we need to do. We need to print these. Now, there were tons of ways people submitted these being printed, and everyone had it formatted. So I am very thankful for that. I know we went over formatting. To me, it felt quickly, but you all picked it up very well. And so I'm really thankful for that. And I saw all three methods that I showed you used. So again, thank you for that. That was a blessing to see, to be honest. So I do want to go over and cover it again, but from what I saw, all of you understood how to format and how it was used and not even just for what you need to do now, but it seems like you might understand it for the long haul too. So yeah, so I'm gonna go back to the shell here and just demonstrate some printing, so or some string formatting. So I'm just gonna create your random string and I'll print it out later. So I want to, how can I do this? I want to enter in some math. I want it to be printed out as a string. So let's see, let's just take, I'm just gonna put a random number here, honestly. Okay. And now that A is 87,897, I want to form this into a string. So some of you, what you did was you had it formatted before you actually printed it, which was completely fine. Some of you formatted it and then entered it into a string and then printed it, which was also fine. Some of you did it all in one line. But let's look at the different ways to format again. So when you do format, I'll call this S here. What we can do is we can use the format function directly, and it takes in data or a value. So I'm going to give it A, and then you give it the specifications on how it should be formatted. In our instance, we wanted it to be 2 decimal points, and so give you guys more of a reason behind the 0.2s and the 0. So I mentioned this to someone earlier, actually, about the 0 and how when you have a list of data points, the 0 tells it which one to go to first, which is true when you're dealing with curly brackets in a list. We haven't gotten into list data collections yet. And so when it actually just works with one value, so I had to actually look this up in the last like 20 minutes before class. That first number here before this period is for padding. And I'll show you what I mean by padding in a moment, and I'll make it really evident to you. But the second part is for truncation. So how many things you want to follow after the decimal. So in our case, we said we wanted 2. And then that last part was a letter of an F. And what F does is it gives us a float value. D will work for digits or doubles. So that'll be how many digits we have actually in place. And then there's I for int. And then there's a couple other things. There's an S for string. Can't see the screen? Okay, I think that's because it's so far down. Yeah, it won't let me scroll down anymore. So I'll do this actually. This. This goes more. Nope. Okay, that's there. And now I can scroll down. Is that better? Can I see there? Is that better? Now let me know. So I will come up with some. No? All right. That won't work either. Okay. All right. I will show you from within what we're actually doing within our code then. So what I wanted to show you guys, is that better now? I can see, okay, good. So we have the format here. F is for a float number. So what this will allow me to do, oops, invalid syntax. Oh, I didn't put it in a string. I'm gonna be lazy and copy and paste this here. Where is it? There we go. Okay. So now when I do that, I got a string that's been formatted with 2 decimal places at the end, F here. I want to show you guys what that looks like with the padding. So paste the same thing here. And this time I'm going to put 12. Again, of course I couldn't do that again. All right, don't forget to put this as a string so it knows to format it as such. Okay, let you guys see that. What do those look different? One has a 0 in front of that decimal and the other one has a 12 in front of it. How do those look different? Anyone? Anyone have any clues of what happened there? Quotes, yeah, the quotes has a lot more room in between them, right? All the way to the left, yeah. So I'm gonna count some things for you guys too. So let's see here. 1, 2, 3, 4, 5, 6, 7, 8 characters used to type this out. Let's look here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12. That's kind of weird. 12 characters that were typed out here. I wonder where we got 12 from. Oh wait, that's the number I put in front. So that's what that padding does. It allows you to determine how many I don't want to say digits because it's not always digits because you could do this also with a string. But it's how much is actually printed out. So if I say 12 spaces should be there, if there's not enough, it will fill it with blank spaces in front. So that's what the padding is. This becomes useful when, let's say, you need to print out a chart of some kind and you want things lined up a certain way. You can make it so that regardless, it will always be 12 spaces, or it'll always fit 12 characters. That way, everything will be lined up. If the largest value on there had 12 characters and the smallest only had 2, everything will still line up. So this is one way you could do that. Okay. In other languages, it takes a lot more coding to handle that, but that's what that's for. So that was one way that you guys could format. You could use the format function directly. If you were to do this, you may need to add it into another string. We saw how to add strings together, and then we can multiply them as well. So that things could print out the way you want it. But if I wanted to now, I could say print S, and it would print out with those 12 pads, or padded to fit 12 spots. If I wanted to, I could say print hey, this is a number. And I could say add S to that. Well, because there's no space or anything here, what this is going to do is it's going to literally add it on, which will be kind of harder for you guys to see, honestly, because of the padding. But it's directly up underneath it. Actually, I'll do this. I'll revert it back because I want you guys to be able to see it. And this time I won't forget to put the quotes here. And print A is a number. And then we're going to add an S here. Boom. Notice how it puts it right underneath it. So yes, you can go back here and do this, and put a space. But you also there we go. We'd also do commas within the print statement. Notice what a comma did. It automatically put that space in between it. Because print allows you to put multiple values and it will concatenate it for you, knowing that those should have a space in between it because it's string. If you're writing text, there should be spaces in between words, right? So that's just understanding the difference between those two, using the plus or using a comma. Okay, that's one way to format. The other methods that we saw involve using the curly brackets inside of a string. So if I wanted to say, everything print. And then if I wanted to, I could put curly brackets here and tell it to get the first entry. Or actually, yeah. Well, yeah, I'll do it that way first. Tell it to get the first entry and to format it. We can do whatever we want. I'm gonna do a 0.2 here, just so you guys can see. And over here, though, if you do that, you need to do a dot format and tell it what's being formatted. So in this instance, this first 0 in front of this colon tells you which item to get. So as you notice with your assignments, we start with assignment 0 and then we move forward from there. In code, when you're coding, we start with the first index at 0 when we're looking at a list of things. It always starts at 0. That's very important to know. I'm going to put a couple of different things in here just so you guys can see what I'm talking about. 9, 87, and I'm going to show you different examples here. So, did I not put a string? For object. Oh, because it's already a string, that's why. It's called A, right? Yeah. So just so you guys get used to that too. So I looked here, it said unknown format code F for object of type string. And so I said, there's a problem with F here for a string. Oh, because I had already named this a string, but this was before A, which was a number, right? So there we go. Now it's working fine. So it got A because that was the 0th entry over here. So let's see what happens here. If instead I tell it to go get the first thing, or which is the first index, so really it's the second thing, because remember with these lists here in collections, we'll start off with 0, 0, 1, and move forward. So do that. It went and got the first index and put it there instead, and it formatted it. Show you again. This time I'll put 3. And the person I worked with earlier today, this is what I was talking about with the indexes. This is the format that you have to use. So when I do 3 here, what does it say? Replacement index 3 is out of range of positional argument tuple. You guys don't know what a tuple is yet. Argument, we kind of talked about. I said it's a part of what you enter into the function. You may kind of understand that. But the fact that it says index 3 is out of range, based off what we just talked about, I put 3 here and I said it should be at the 3rd index. Well, there's 3 things here, right? But there is no index 3. Remember I said we start at 0. Can't see again. Come up. There we go. I can do that. There we go. There, good. And thank you guys for continuing to remind me and tell me things like that. That's what I need to know. All right. So in this case, the 3 says it's out of range, but we have 3 items. But again, remember we start our list items at 0. So we have 0, 1, and this should be a 2 if we want to use the 87. This should be a 2 and not a 3 if we were going to use it. So I'm gonna go in here, put a 2 there just so you guys can see it. Oop. I'll move it up a little bit there. You can see it too. All right. So that's the second way to format. I showed you guys also how to format using the %, which is actually very similar to this. F. So the difference here is on the outside with the format, instead of format, we do the same %, and then we tell it what it is that we're putting in there, and I'm gonna put A in there. So I'm gonna put this up a little bit so you guys can see. So This is another way to do this. This is actually the oldest way. We'll use a placeholder, and outside the string we tell it, hey, for that placeholder, put A in there, but format it the way I told you. Okay. Then the new way, which I told you guys is the fastest way, and I was so thankful to see some of you actually remembered that, and that's the one that you use. It's the fastest way, it's the newest way, it's the most efficient at runtime, and that's when you have the string, get rid of format. You put an F in front of the string, the letter F, and that lets Python know that I am going to format this somehow. And what you put inside the curly brackets is the thing that's being formatted first, and then you put a colon, and then afterwards you put how you're formatting it. So bring that up again. So what I did here was you put an F in front to say, hey, this is going to be formatted. And there are other letters that you can use to do different things. We may see those in the future down the line because they are newer functions within Python. We have our string. Looks pretty normal, except there's these curly brackets. These curly brackets let Python know, hey, this is where I'm going to do some formatting. Within the curly bracket, the first thing that you see is to be a variable or some kind of calculation that's being done. So in this case, it's saying, hey, go find whatever A is equal to. In our case, A is 87,897. After that, you see a colon, and you're telling it how to format A. All right. Are there any questions about formatting? No? All right, excellent. So there was two other things with strings that I did want to talk about, and that is using the escape characters. So within a string, so actually I'll do it within our example here. So I didn't want to completely show everything because the last part of this should be you guys print it out for those of you that need to go back and make some corrections and changes. And also note that these are ways to do it, right? You can have different variables you use. You don't have to import just squirt. If you want to import all math, you could do that. You didn't have to use the double asterisk for exponentiation. You could use the how. You didn't have to use squirt either. You could use to the 0.5 power, or you could have actually divide it to the 1 divided by 2 power. There was another formula for area. So there was a lot of different ways to do this, but this is just an example so you guys can see the importance also of workflow. So of planning things, of understanding your problem, planning it out, coding it, and what we've been doing is testing it. When we had issues, we went back and said, oh, that was the error, let me go change that. And then the last part, once we do a final test, the last part would of course be to document it. Oh wait, that's already been done because we copied and pasted earlier. And there may be some things that you tweak in your documentation within your comments. But for the most part, you already have that done because you planned it out. Okay. So does everyone understand that importance between understanding the problem and planning before you jump straight to coding? I hope that's really clear because that's really important. Really important. Okay. Cool. So I'm gonna play around with a couple of other things here. So with commenting out, I did not see anyone do this, which I'm thankful for. But I do want to show you that if we had wanted to, we can do, let's see here. We can do something that's known as a multi-line string. And I want to show you all what that looks like. So I'm just call this answer. So what a multi-line string is it allows you to, I believe actually I did talk about this last week. I may have briefly mentioned it, but it allows you to write out your string on multiple lines. You don't have to worry about it forcing you to close out or having to use those new line escape characters. So for instance, if I just typed a bunch of random stuff, notice how it's continuing to go over here. I can't even see the rest of my code anymore, right? That's an issue. Not that big of an issue, but if I have a super long string, it's going to get really annoying. I'll go to the next line though. That's an error now, right? Because it doesn't recognize that it's still a string. Well, in most languages, this becomes a huge issue, and that's when they start doing the new line characters and they go to the next one and be like, okay, answer plus equals. Remember, that's one of those compound operators, meaning that it's still going to, you're going to take answer, and it's going to be equal to answer plus whatever we add afterwards. As we saw last week with these compound operators. It sets this variable back equal to itself while adding, subtracting, multiplying, dividing, whatever operation we put here along with it. But instead of doing that, what I can do instead is what's known as a triple quote. Notice how it's still a string, even though I'm going on all kinds of lines. I'm even tabbing in here. It still sees it as a string. Triple quotes allow you to have multi-lines, meaning multiple lines, and it really will register this as a return character and so on. So I'm gonna run that. Well, I'm gonna print my answer here, ANS. So glad my F5 work button is working now. So it's still asking the rest of that stuff, and boom, print out all that garbage. But notice the return character is being used here because it goes to the next line when I press the right arrow. Everything else, the spaces and the tab as well. All of that's including in here already. Moving my screen to the left. Actually, this. You see it a little better? Yes, okay, good. All right. So it kept everything that I had in that multi-line. All the returns, all the spaces and tabs, everything is in there. Okay. So that's how you can do a multi-line. Now, some of you may see in some documentations somewhere that they say that multi-lines can be used for comments. That is not, all right, I said it. That was not its intention when it was created. You should use comments with the hashtag. You should not use multi-line. Multi-line will work as a comment and will not register as a string because it will, Python is seeing it as, oh, this is a multi-line string, but it's not saved to any variable, so I don't care. And that's what it does. It'll just ignore it. So sometimes people say, oh, it's a comment because it's being ignored. Well, it's not. It's not a comment. That's why it doesn't come up in red text. It still comes up as a string because it sees it as a string. So do not use multi-lines as a comment. That was the purpose of me showing this to you. Well, one purpose. The other thing is because you can use this. All right, you guys may need to type some things out in the future. Wink, wink, thinking probably 2 weeks ahead in homework assignments. May need to use multi-line comments, maybe, or not comments, multi-lines strings. How multi-line string works, you use triple quotes. And I say triple quotes, use triple quotes. And when I say triple quotes, I mean triple quotes. So that's triple quotes. That is also triple quotes. Okay. Notice the difference. We actually call these double quote and single quotes. You guys may call them quotations and apostrophes. You're correct. We're also correct. This is the traditionally these are called double quotes and single quotes. So this is how we use them. Okay. All right. I believe are there any questions about using the different operations? Want to have any? No. Okay. Just because of your assignment is coming up for this week, I want to be sure that you guys understand that there is a difference between integer division and float division. So, and I'll make sure I move this up. For instance, if I did 8 divided by 3, this is what I get. $2.666. This is float division. Integer division, put it 8 divided by 3. Starts divided by 3, and I put 2 slashes instead. Notice that it gives me the number 2 as my result. I got 2.6666 up here. Down here I got 2. Integer division will automatically round it down. So if there's any decimal, it just, honestly what it does is it completely truncates off the decimal and just returns the integer result that you got. Okay, so that's important to know because you may need just the integer result. You may not need the float result. Kind of thinking ahead for one of your future assignments, and you guys, you actually use this in your real life. And let me give you an example. If I gave you a bag of coins, and I asked you to calculate how much money there was in there, or if I told you to, or if I gave you an amount and I said I want this in quarters, dimes, and nickels, pennies, the max I can get of each because I only want coins. So if I said give me $12.73 in quarters, dimes, nickels, pennies, or if I gave you just a bunch of coins and asked you how much money would be, how would you do that? Well, for the $12.73, you may say, oh, well, I'll need 4 quarters for each dollar. And then after that, I'll need 2 extra quarters, right? Because I said 73 cents. Well, how do you know that? Because you know that you can take that 1273 and divide it by, actually, let me do that here. 1273, if I were to divide that by 0.25, which would be a quarter, it would give me 50.92, and I'm going to move this up in a second, but I'm also going to do integer division on it. I want you guys just to see the difference here. I did float division, I got 50.92. I did integer division, I got 50. Which one's going to be more beneficial to me if I'm just trying to figure out at this point in time how many quarters I need? Yeah. So when he says integer division, if you use the result here, you could use this result, right? You could get this result and just forget about the part that comes afterwards. You could totally do that. But think about if you ask the computer to do this for you. Now you have to tell the computer to get rid of the 0.92 and not worry about it. Whereas this way you don't have to because it's already an integer, right? Because you can't give off of a fraction of the quarter anymore. They used to be able to do that back in the day. You can't do that anymore. So integer division is useful. So I know I've had people in the past think that, well, who cares about integer division? I just use float division. Why would I ever use that? Well, this is just an instance in where you might want to use it. Modulus, something else that's very important. Modulus. Remember, modulus gives you the remainder when you divide. So if I were to do, let's just do the same thing, 12.73 divided by 0.25, let's see what that remainder is by doing modulus. So that's the percent sign. So you'll notice here that I get this 0.23 and a bunch of zeros and then a 43. Let you know now that 43 there at the end is crap. There are some things that occur. There's a reason it's there. But in reality, our actual remainder should be the 0.23. So in this case, I would probably tell this to truncate off until you only have 2 digits left. So how could I do that? Well, I'll just type it again, I guess. 12.73 mod 0.25 is what I'm calculating. I'm going to tell it to be okay here. Format this so that I only get 2 decimals as a float. So if I format it like we saw before, I can make sure that I only get those 2 decimals. But there's a possible issue with this. This is going to return a string again. How can I make it go back to being an integer? Or sorry, in this case, a float. It formatted it as a float, but it's not in the form of one. Well, what I could do is just say, make this a float. So I could typecast it like we did before. So I could use the format, any of the 4 different ways that you guys will learn how to format. I could use that in order to format it the way I need to see it. And then I could use typecasting to put it back into the data type that I need to work with. Okay. Are there any questions? No? Okay, good. Good. Let's see. It looks like I went over almost everything. Well, I went over everything I wanted to go over today. Are you all sure there's absolutely no questions? Because if not, I will move forward. Anyone want to see any examples of anything that we've looked at so far? No? All right. In that case, I'm going to actually open up a new file so we can work with, and that way we won't have to worry about scrolling as much either. Could you go over over the formatting placeholders? Yes, I can. So, oops, the wrong one. Let's do that here. So, format placeholders. So, if I had a string, or actually, and this makes more sense to do it with a number. So let's just say I had a number. I got a number. Great number. I'm gonna use pi because it has a bunch of digits to truncate and stuff. I'm gonna do from math import pi. Okay. So I'm gonna do pi times. That should be a good number there. And I'm just doing that again just so I could get my number. I'm gonna print it just so you guys can see what it is as an actual value. So for the different types of placeholders, you could use the %sign as a format placeholder. This is the oldest way, and it's also the slowest way to do this, but it still works fine. And a reason I'm showing you guys this is because if you ever use Python code, if it's older code, it's going to have these. And even people that are coding now, they may still think this is the only way to do it. So if you see that, you can go in and make those changes yourself within, like if you at your jobs, your future jobs, if you're ever doing this, you can go make that change. That's the real reason I'm showing this to you, because you really don't want to use something that's too old. But how would we do this here? Well, we print, and I'm going to say that just put something random. This is a number, and I'm going to put my %sign here. And what that tells Python is that there should be something else following outside here that's not a string. Otherwise, I would just concatenate the string directly. Could be a string. No, and I'm just going to put A here. And so this is going to directly input whatever it was that I gave it. And so if I were to run this, which is going to save it, I have to give it a title. So I'm going to call this testing 02.1. Oh, I can't use point, -1. Okay. I forget to Oh, I did. I forgot to tell it if it's a float or something. Give it an F here. Do that again. There we go. All right. So the percent, and I needed to tell it what it was. So it's going to be a float value, or that's what I wanted. I want it to be a float value. And so it went over, and I'll move this up a little bit just so that you guys can see, definitely see. So it went over, it printed out the value first. So this is the value we had. And then it says this is a number, and I told it to just take this value and put it in as a float. Well, as you guys may notice, it actually rounded up at some point. And there's a reason for that. Let's see how many characters we have here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. There's a limit to how much it will hold for a number. And there's a limit to how much it will print out for a float number in a string. So that limit, even though we can specify one, right? That's what you all have seen. We've put like 0.2 a couple of times. And I showed you guys how you can do the padding in the front as well. You can use that as well to do so. But you can limit it all you want. But this is, it's going to automatically have its own limit anyway. So, but let's go back and let's make some changes here, or do a different example. And I'm going to try to be lazy. Copy this here and paste this here. And let's have it, do 10 things, and I'm going to tell it to truncate after 4. And I'm going to run it. And the purpose of me doing that again was just so you guys can see the difference. So here it was, just straight up, here's a number printed out. Here's a number being replaced into a string. It has a limit to how much it is as a float automatically, just because of the limitations on the string and how much it can hold. And here it is, we said we only want to have 10 padding, which this actually will go over. But we said we wanted 4 decimals showing, so that's why there's only 4 decimals showing, and it rounded it off. Okay. That's one way to do it. We could also do it using format. And so I want to print format, tell it to take A, and then I gave it the format specification. So what it is that I want it to be. So I could, and like we did earlier, I could just honestly just put F. I think that would be kind of a waste, but did I add too much extra? Gonna get mad because of the F here. Yeah, it is. Oh, okay. Well, I'm gonna make this mistake again. Oh, I'm gonna make this mistake again so you guys can see what just happened. Okay. Unexpected EOF while parsing. Does anyone have any idea what that means? Maybe not, especially if this is your first time doing it. But yes. So Renee caught on to what it is. It's missing the extra parentheses at the end for print. But let's say you had no idea what that meant. What could you do? Yes. The correct answer. Google it. EOF stands for end of function, so it expected some end to the function. Sometimes you may see EOL, so that's like end of the line. It's expecting something at the end of the line. But while parsing, it's just like as it's going through it. So it's like, hey, something's off here. So good catch, Nay, for the parentheses, and good call, Jocelyn on the Google. Because if you don't know it, you can Google it. And it comes through. And notice how when we use just F here for formatting, we get the same result here. Right? Still formatting it the same. So, and if I wanted to, I could use format again. To do like we did earlier with the 10 and all that. I'm gonna do 16 this time because I like to change it up. And then I will remember my parentheses this time. I will press run. Notice how we still get the same thing for the forward end, but this time with the 10 padding, it's all being shown there. We got it. Or 16, I said, right? Yeah. So that's why we have this extra space in the front. 1, 2, 3, 4, 5, 6, 7, 11, 12, 13, 14, 15, 16. 16 things being shown. Okay. And we had the other methods as well. I would personally, I would say the other two are going to be most useful to you as opposed to these. Again, the F in front is the fastest, so it is the one you should go to. However, the other one, F may be confusing to some of you, especially when we start looking at list of items, because may not understand at first how to go through each item. So let's see. Using format and these guys. So if I were to print and I had my string, this is a number, and I did this, I can start off by just straight up putting A in there. No problem whatsoever. Within that squiggly bracket, and it automatically will know that, hey, it should be, oh, actually it won't, because I didn't put any formats in here. Dot format. And I'm not going to do that. I forgot which one I was using. Sorry, I was thinking about the F. I'm going to show you each guys in order. So using the dot format method, we have a dot at the end, a dot, and then the function is called a method. So in this case, this is a string method because you're doing a dot with the function on a string. And we'll talk more about that throughout this semester. But I can say that this is A. And I'll put my closing parentheses at the end here. And so what this is going to do, it's going to go and it's going to look for that first entry. If I had multiple things within this list, I'm just putting random things in here just so we have more than one thing. It got the 0th entry because I put a 0 there. I'm going to copy and paste this. Easy. And I'm going to have it get the first thing. And I'm going to do this again. And I'm going to have it get the second thing. So, from that, it got the 0th entry, it got the first entry, it got the second entry. That's because our list in most programming languages, you begin at 0, then 1, then 2. That is literally the reason I did that in your homework, was so that you guys would have that kind of understanding in your mind. In case you ever forgot, you can go back to think, oh yeah, our homework started at the 0th. Meaning that was really our first thing. But as I was saying, this might be more useful, especially when we start looking at using lists. This might be more useful for you guys because you can see that, oh, I need the 0th thing, the first thing, the second thing. But that's not the only way to do that. And then, of course, you could also add a colon and do the formats after that. So I'll do one example here just so you guys can see. So let's go back to our plain old point to F. I didn't put a 0 in front this time. I'm just putting 0.2. Okay, so I just got 2 decimal places. All right. And in the coup de grace, using F format, this allows you to directly enter in whatever kind of function or whatever you want within the curly brackets. Other languages call this interpolation, because you're kind of you're interpolating or kind of trying to figure out internally what should go there. I need to put an F in the front of my string. So this is a number, and I'm going to put curly brackets, and I'm going to put A in here. That's what we had. This is also a number. And just so you guys can see what I'm talking about on how you can do different things, I'm going to put 4 to the 3rd power within this. And let's see what happens. Let's see what it prints out. It printed out 64. Why didn't it put the 4 to the 4th power thing? Because as I said, it actually will do the calculation there. I showed you guys last week and a couple of times this week how you do it with variables that are already saved. And I mentioned to one of you, at least when I was working on helping you with your homework, that you could actually put those calculations directly within to the string using the F. Because the F is going to tell it how to format it. The first part that goes in front of that colon is what's actually being calculated. So if a variable's there, the calculation is, well, what does this variable point to? Oh, it points back to here, pi times 1,000,000. Over here, it's saying 4 to the 3rd power. So that's what it's calculating. If I wanted to, I could even give that a format. I'm going to put 3 decimals at the end of it. Notice I get those 3 decimals at the end. Okay. So it's really the use of using F to format is very powerful, as you all see. You can put those calculations directly within the string, which is very helpful, especially because in the past, like as you all saw, we would have to create variables somewhere else. Or imagine have this huge, well, in my past, in using this, we could have the calculation being done here, but imagine you have a bunch of those having to keep putting them back in the string. You have this percent sign, you have parentheses and a list of different things it has to go through and know what to replace for each one. And it might be doing calculations on the spot for that. That takes a lot. So it's sometimes faster to save it as a variable. In this case, we wouldn't have to worry about that anymore. We can directly just type it straight in, and it's going to do it on the fly and format it. And you can have multiple different formats, multiple different calculations going on within a string. Wow. Like, I wish you guys could, well, you could if I should put my camera on. I'll do it for a quick second. Hopefully no one gets kicked out. But wow. Seriously, that is crazy that you're able to put all that there and it's able to handle the calculations directly within the string. Like it literally blows my mind. I think I told you guys I found this out just a couple of weeks ago because I try to keep up to date with changes that are happening within Python so that I can stay up to date with it. But yeah, so that's the different ways to format, and that's how you can use them. That's how you use those placeholders within formatting. If I were you all, I would continue to try to use this, unless you have trouble with, like say, using the calculations in front. A lot of people still are used to this, especially if you are like Googling for help to like see examples that people have done. You're rarely going to see this because it's new. You're most likely going to see these, and then even in the videos that I supplied for you all, or I linked you all from Professor Steady, he's using format. He's using the function and method version of format because again, this is new. So, all right, other questions. I can go over anything that we've gone over. I do have other things that I'm willing to start, but I don't have to start and go over them until next week either. So, if you guys have questions, ask them. If you want to open up your homework and take a quick look at it, we can do that. I'll give you like a 3 minutes. You can take that to kind of stretch and stuff. Hope you haven't been sitting for almost 2 hours now straight. You guys remind me to take those breaks. I need them too for my knees. But you can look at your homework and maybe think about, hey, what does this mean? And actually, maybe I'll do that. I'll pull it up too, and I'll kind of read through what your homework is for this week. And remember, it's important to understand the problem. So us going through it so you guys can have a clear understanding of it will help you with planning. Planning will help you code. Okay, I hope that was very clear with you all today. So that's the other one. So let me make this a full screen, and let's look at your next assignment. Oh, I got logged out. Okay, look at your next assignment for this week. Oh, pennies to dollars and change. I guess I talked about that, right? Talking about float division helped me with the pennies assignment. Yeah, I guess I may have given you guys a big hint earlier, right? I even mentioned this example. I'm still taking a little stretch break, so don't worry about like you might be missing out on something. Okay, let's just kind of read through these, look through this, and then we have one more after this. Oh, found an error. All right, that's about 3 minutes. So assignment number 2, pennies to dollars and change. So with this assignment, this is to help practice with the interdivision and the and modulus operations, getting an input as an integer and also concatenating outputs. Concatenation, again, that's when you add those strings together. Zip on the second file, or it's on the second assignment. What do you mean by zip? Does it say that? Oh. What do you mean by zip file? What do you mean by zip? Are you saying zip file, or are you saying to use? There's a zip function. Sorry, that's what I mean. Temporary conversion.
Assignment 03 it says zip both. I'm talking about the assignment 03.
I am so sorry. I'm not sure what you. Oh, the temperature conversion. Gotcha. On assignment 3. Okay. Gotcha. Yes. I will explain that as well. So thank you for reminding me of that. And remind me again. I'm gonna talk about assignment 2 first, but make sure I mention the zip file on assignment 3 and why I'm asking you to do that. So for this assignment, we got little Stacy. She's been saving her pennies in the jar. So every 3 months, she takes it to the bank and wants to know how many dollars, quarters, dimes, and nickels, and leftover pennies that she can exchange for her pennies in the jar. I used to do this when I was a kid, and I would calculate it out and take it in, and sometimes they would tell me I was wrong, and I would demand my pennies back. I knew how much I had counted. Or you put it in the machine, you're like, the machine didn't count it right, and then they have to pour it all out. It's kind of funny to watch, actually. But we're going to write a Python code to help with that. So you give it the total number of pennies, and then it calculates the maximum number of dollars, quarters, dimes, nickels, and remaining pennies that should be exchanged. So the idea is I'm going to enter in a number, and here's an example that you see here, and how it even printed out. I'm going to enter in a value. Say I enter in 867 pennies. It should output how many dollars, quarters, dimes, nickels, and pennies that is. How it does that is up to you. I do at the top here. The purpose of this is for you guys to practice using integer division. As I mentioned earlier, you don't have to technically do integer division. This you could do float, but float gives that extra bit sometimes, right? That you would then have to tell it to ignore somehow. And using modulus was the remainder, right? So using a remainder, and getting inputs as integers and provided concatenated outputs. So you're going to save your file, print the project title on the first line, print the next line showing your name as a developer, followed by a blank space. You can use this You don't have to. I showed you guys just now multi-line, right? You don't have to use that to do a new line. There are other ways to do new lines. Then provide a description of what the program does. This is the part of documentation. The user should be prompted to enter the total number of pennies. So however you enter that, and you can have it so it prints out stuff that looks exactly the same as this, and that's a good way for a lot of people, especially when starting out, to format things the same way they see it here, so that way they have a place to kind of reference back to of, oh, does this look right? I'm not going to worry about that. Oh, did you use a tab here? Or does this count for the appropriate amount of spaces? I'm not going to be doing that. I'm going to be looking to see how you code it and did you answer the problem. The problem was that if I give you, or if the user enters a certain number of pennies, you tell me how many dollars, quarters, nickels, quarters, dimes, nickels, and pennies that equates to at the max or at the minimum. So I want the max of each of these that I can get. Yeah, don't overpay and underpay. So those pennies better be in there. As you guys may or may not know, we are in a coin shortage in this country right now because people stopped using them because no one was buying with cash. Before that, people were burning, and actually I've seen videos of people still doing it, but they've been burning and using pennies for nothing or throwing them away because they say they don't matter. Pennies have feelings too. Use those pennies, they are coinage. So they are important in this assignment as well. They should be involved in here. If you put a funny quote about pennies not having any real value, I will probably laugh. But I'll also give a stern comment back about how they're important. So, but all your output should be displayed with labels, it says. How you label is up to you. I've gotten something fancy where someone made a table that said dollars here, quarters, dimes, nickels, and then underneath it, it had each of the amounts going across. That was very cool to see. Someone else made a clear column where instead of these colons here, they had, you guys may have it on your keyboard right above the enter key. So the other slash, if you were to hit shift in that, it would be a straight line, a vertical bar. They did that and they put it in the same spot going straight down. That was cool. So I say that because I want you to meet these requirements, but not feel like a stickler for it looking exactly like this. Again, this is a great place to start. And if it looked exactly like this when it printed out, I'd ask you, why did you say your name was Stephen Steady? But besides that, this is just a good place for you guys to reference on how it should probably look like. Here's a description. You might not describe it this way. But I also expect in your code to see some documentation this time. And eventually, I may change the rubric to actually take that into account because it is very important. And as you guys saw, it makes things easier too because you can plan it out and use that as your documentation. So that's assignment 2. Are there any questions about assignment 2, or anyone have any questions about possible ways to begin or things that they should be thinking about? No? All right. You said to use the modulus. Yes. Well, that's a part of the alignment here of the purpose of this is for you to get practice with that. You technically don't have to use the modulus, but remember the modulus returns the remainder of a division problem. So for instance, if I were to do, say I wanted to print out 8 mod 3, what that would do is it would say, okay, well, 8 divided by 3, I know that's 2, but the remainder is 2. And that's what it's going to give me. It's going to give me 2 because that's the remainder. That's how much is left over when an integer divides it. So when thinking about if I give you a bunch of pennies and you needed to know how much is, like, you figure out how many dollars there are, well, how would you figure out how many dollars there are? Okay, well, how would you figure out how much is left over once you divide? How would you figure out what the remainder is So you can move on to the next thing for quarters. Okay, so maybe that modulus may play a part in that. Okay. There's other ways. You don't have to use modulus. There's ways to do it without it. The purpose is to practice with that, but you may decide, I don't care about modulus, I'm never using it. I had one friend in college that would do that, and we used to laugh at him, but he got all his assignments done. And I'm not talking about even just coding with Python. In math, when we were doing some things with numbers, and with algebra, when it comes to number theory, modulus comes up a lot, especially when trying to figure out something is divisible or not. You should have a remainder of 0, right? If it is divisible by that number. So for instance, if 729 is divisible by 3 and 9, I know that because when I divide by it, I get a remainder of 0. Well, every time we did problems like that, he would never use the modulus, and he totally could have. It would have made it a lot faster. But you don't have to. That's part of the beauty here. Like technically, if you want to multiply things, you don't have to use multiplication. You could just use repeated addition. But that probably wouldn't be the best thing, right? So, all right. Are there any other questions? Or actually, let's print this so you can see what this looks like again. So it gave us 2. The modulus always returns the remainder. Okay. All right. Nothing. Any other questions? This one? Okay. All right. So for the next thing here. Oh, is it this one? Okay, this is so important. Okay, for the next thing, as someone mentioned, I say that you need to have a zip file. So zip both your PY files together, and then upload your zip file to Canvas. There is a reason for that. That is because it will keep it all together whenever I download it. Also, it keeps it together in the form of, I know that you are the one that submitted it. It also compresses those files, and it makes it easier to understand, so it's smaller. In case I needed to. If you zip something, it compresses a file by looking at what's in common and then pretty much making placeholders. So it knows that, for instance, if the letter A was repeated a bunch, it can use A one time and then have a separate file that's a part of the file that says, oh, A is this placeholder if you ever see it. And then it will use that placeholder everywhere else. So that way it can save bit size. And because some things don't take up as much space as others. And that A is a silly example, but I usually use the example of the rain in Spain lies mainly in the plain. There's a lot of AINs in that thing. So AIN was equal to some placeholder. That takes up less space instead of writing that over and over again a bunch of times. But anyway, that's what the purpose of a zip file is. So how do you zip? There was a thing in the, I believe I had it in the first week. Or in the, yeah, it's in one of the unit zeros or week 0 things, showing you how to zip a file. But very quickly, I'll just give you guys an example, which that didn't show up. Okay, so oh, funny. Here are zip files. So let's just say I wanted to zip this file, or that's already a zip file. So let's do something not. So if I wanted to zip this file here, what I could do is I could right click on it, go to send to, and then compress folder. And then it would make a zip file. If I wanted it to be multiple things, I could select each part, right click, do the same thing. Send to, compress folder, and now I can name it whatever I want. It'll automatically give me a name based off what was there. Zip example. And both of those things are now in there. And so this is what I would upload to Canvas for this assignment. So this is what I would receive from you all, the zip file. Okay. That also it becomes a good practice, especially when in courses such as this, not just for size purposes, but there are going to be times where you may create a file that needs to reference a different file. Kind of like how we're referencing the math module, we're importing that. We may get to a point where we need to reference another file. Well, I don't have that file if it's on your computer, right? So you'll need to zip it and have it all be together. Even if you import it separately, when I download those, they won't necessarily be able to connect to each other, especially if all of you name it the same thing, right? It'll be easier for it if it's all in one folder together. Well, that zip file will create that by doing that. So that's why I'm asking you to do that. So let's look at this assignment here, temperature conversions. The purpose of this is for you guys to practice more stuff with input and mathematical calculations and formatted outputs. Let's see what the problem is. This assignment is actually 2 programs. 2 programs means you're turning into 2 program files. So 2.py files, again, the reason why we're zipping them together. One will accept a Celsius temperature provided by the user and then display the equivalent Fahrenheit temperature. The other will accept Fahrenheit temperature and convert to Celsius. If you're not sure how to convert from Fahrenheit to Celsius, you can look it up online, Google. But there's also a formula provided here, but you have to understand how this formula works. For instance, you need to know what F is and what C is. But I'll give you a hint. F is the first letter in Fahrenheit. C is the first letter in Celsius. So these variables were appropriately named variables. So F stands for Fahrenheit, C stands for Celsius. And I just did that just now, not making fun of anyone, but for you to understand the importance of naming your variables and how it makes it easier for people to understand. Right? You could even put FAH on here or CEL if you wanted to, right? Or degrees F or degree C. But anyway, here are the calculations that you do. Be very careful with your order of operations in case you do this in certain ways. Python will take care of order of operations for you, but just be mindful of that if you decide to split this up. Order of operations is important, but the formulas are there. You'll save your 2 files and then you'll zip them together as one. Make sure you document in both files. Document in both files. It says use float type variables for input calculations. So that's given straight here. Use floats. So there shouldn't be a question of should I take what the user enters as an integer or not. It should definitely be a float. Your output should be displayed with 1 decimal. 1 decimal. Okay. And as a cool trivia question bonus, there is only one temperature that is the same in Fahrenheit and Celsius. If anyone can figure out what it is, you get brownie points. So this might be a fun thing to test with this guy. All right. Are there any questions about this assignment? Number 3. All right, someone is really learning, and I think a lot of you are. Google is a good way to find things. So -40 is the correct degree that actually will do it. At the bottom of the rubric, it says add rubric. What is that? Oh, A00. That's just me being lazy and using the rubric from the previous one. Because remember, this class, your assignments are graded based off of the student learning outcomes. So that's what the CIS150 stands for. And the one that I'm testing here is the same that I tested in the last 2 or I guess the previous 3 in this case assignments. So that's why it says that, because I just copied it from the first one because it's the same. I was being lazy. I'm sorry. But this is what I'm looking for. Did your Python program that you wrote take user input and display formatted outputs? And that's what you're instructed to do, right? You're going to take user inputs, you're going to do some calculations, but you're also given a formatted output. So I say at 1 decimal place. Someone did ask me, do you guys have to put fancy sentences when you print things out? You do not. I asked specifically how things should be formatted. How you interpret that is up to you. However, think about this. Does it look good if you were to just put, in this case, enter 100 and then you just put 212 come up, 212.1? Sure, but that person may not understand that's Fahrenheit, except for the fact that you have a description printed out too. You don't have a description printed out, they won't understand that they just gave it Fahrenheit. So sentences could be good things to do. You may even want to try to figure out how to, and this is just added. Once you get the program good to go, you can go in and add things. And I suggest doing so because it helps you learn. You could try to figure out, well, how do I, let's say instead of doing 212.0 and then put degrees Fahrenheit, what if I actually had the symbol for degrees be up here? And then Fahrenheit, how do I print that out? That might be something to do after you've finished this and you go back to how could I tweak it to make it look better, okay? All right. But negative 40 degrees is the same in Celsius and Fahrenheit, as someone else pointed out by going to do a Google search. Thank you for doing that. Brownie points to you. All right. I was truly. I know you weren't interested in the brownie points. Yeah, it is actually really cool to see that there's a temperature that's the same between them, between Fahrenheit and Celsius, and it's the same either way, and that's negative 40. So if you were to put negative 40 in here in this equation, you would end up with negative 40, and if you were to put negative 40 in this equation, you would end up with negative 40. So it's kind of crazy. Yeah. All right. Okay. So I have about 17 minutes left. If no one has any other questions. Do you guys feel more confident going into this one? I purposely did the triangle calculator assignment in the first week because I wanted to see how people would do, again, with the information that was given to you all earlier. We went through everything that you needed with that, but we didn't pound it. Like we didn't go in and hit everything very hard, right? And we've spent a lot more in detail to date on those things. And we even went through it as an example. And the main reason I did that is because I wanted to see and I wanted to show you, because I knew most people would probably go straight in and start coding. They may go in online, look at examples, and take those examples and try to tweak it to make it into their own and what they're doing, which is good practice. But before you ever do that, the first thing you need to do is understand exactly what's being asked of you. So understand the problem, then plan before you ever code. I don't care how many years you've been doing it or how great you are at it, you still need to do that first. And so I wanted to make sure you guys understood that as well. So, all right. So make sure you always plan out what happens in code before you go straight to do it. So, go back to my shell. Where's that? So, one other thing I wanted to review is there were two data types. We already said there were 4 data types were, as you guys have mentioned a couple times, so I know you know what they are. Strings, integers, floats, and the last one was Booleans. And Booleans were our true and false. And so we had some special keywords. I guess I'll put it in the SAPY. So Booleans are true and false. And we have ways to calculate Booleans. We have special keywords that we can use as well to do so. But you can, and you'll see that these turn a certain color because they're special keywords. These are Boolean values. So the purpose of them is to see if something is true or false. Because sometimes when you do coding, for instance, if you were to do the temperature project as 2 files, and actually, you know what? I'll do this. I'll throw this out here. There is a way to do it as just 1 file. Put it all in the same one, but you can't use a function to do so. Or you can, but I don't want you guys to because we haven't talked about that yet. But there is a way to put it all in one giant file, and that has to do with using Booleans in a way. Because if let's say you gave the user another question first. Type F for Fahrenheit, type C for Celsius. Then you could, next question, you would know to particularly ask them what the number is that they're asking for in Fahrenheit. Then you could translate to Celsius. Or type F if you need to convert to Fahrenheit. Type C if you need to convert to Celsius. Next line, they enter something in, then you tell them for the degrees that they need for you to convert, and then you do the calculations. Wouldn't that be nice instead of them having to open up two different files? Well, if there was a way for you to ask for you to ask them that, and then to take that information and then to see if it was truly Fahrenheit or not, that would be nice, right? Well, that's how we can use Booleans. So before you begin, though, it's very important to understand, again, how Booleans work. So ways we can test Booleans or get Boolean results is we can test for equality. So if I wanted to see if, let's see, if 8 equals 8, or in this case, 8 equal 9. 2 equals. Allow me to test for equality. Of course, we know that an equal sign is being used to assign variables. Equal means equals. This 2 equals is testing equality. Okay. I'm going to print these out so you guys can see what these are, of course. We saw other ones too last week. We saw greater than, which you guys know. That's the symbol here, greater than. So we can see if something is greater than. So I'm going to do is 7 greater than 8. And let's do is 8 greater than 8. Let's do is 9 greater than 8. I'm doing a couple of these just to test so you guys can see. Likewise, we have less than. Get lazy. Okay. Let's see what a couple of these say off the bat right now for just those. Notice how they give true and false, because we're asking Python to calculate whether something is true or false, because we're testing something. So hopefully you guys can all see that. Move this over. So the first true here, we told it just is true, true. Well, true is true. False is false. 8 does equal 8. 8 does not equal 9. 7 is not greater than 8. 8 is not greater than 8. But 9 is. 7 is less than 8. 8 is not less than 8. 9 is not less than 8. So these are how we can test. So we can test using equality, using greater than, using less than. Of course, we could also use less than or equal to and greater than or equal to. I won't use an example because I feel like you guys can kind of beginning to understand this. But these are different ways that we can test for things. And we could even get a little crazier with this and have some calculations that we're testing. For instance, how do you know a number is even? How do you guys know if a number is even? Anyone got an idea? Can be divided by an even number? Hey, that's not necessarily true, but you're on the right track. It can be divided by an even number most of the time. Divided specifically by one even number, and that is 2. Yes. So check for an even number. So one of you mentioned we could use equals equals then, based off what I just taught you guys. Well, question is how? So you guys said that an even number is can definitely be divided by 2, right? So let's say num equals, and I'm going to take a integer value from my user. So we're going to do input. And what I'm going to ask the user to input is to give me a positive integer to test for being even. Okay. Actually, I'm going to do something there. I'm going to put a new line if I can. Okay. So we got the num, and one of you said we're going to have to use equals equals in order to test for equality. Well, what is it that we actually need? If we're taking this from the user, what is it that we're going to need from them? Or what is it that we need to test with this number to see if it's even? This goes, yes, we should be planning this actually. So check for even number. You guys told me to plan though. We need to check to see if it is, excuse me. We need to check to see if it can be divided by 2. Evenly. So what does that mean? How can we code that? How can we code to check to see if something is divisible by 2? Anyone got an idea based off? Think about the operations that we've learned about. Can any of those be used to see if something can be evenly divided by 2? Got addition, subtraction, multiplication, division. Anyone got any ideas of ways to test it? Well, we have addition, subtraction, multiplication, division. We have integer division as well as float division. We also have a modulus. We have PAL, we have squirt. We got a couple of things in the math module. Any of those, though, that aren't in the math module sound like something that you possibly could use to see if something is even or not? You guys already told me it has to be able to be divided by 2. Okay. Well, there are 3 things that we actually could use to see if this is going to work or not. We could use float division, because I could just take the number and divide by 2 and check to see if the result has a decimal. If the result had a decimal afterwards that wasn't 0, then it's not divisible by 2. I can use integer division as well, because I could do integer division. You know what? I'm going to just do some examples here. So if I were to do 7 divided by 2, I get 3.5. So I could check the end of that and see that it says 0.5. It doesn't say 0, or it does exist. So therefore, it's not even. If I were to do 7 integer division, I get 3, and I can multiply that back and subtract it from what the user gave. If I got a result, then that means it was definitely not. If I got a result other than 0, then it's not going to work. What about modulus? I do 7 mod 2. I get 1. I get a remainder of 1. What kind of remainder should I get if it's supposed to be even? 0. Good. There are 3 ways to do this. Based off kind of what I said of having to go and get the ending part of this and checking to see if the ending part is 0, that might take a while, right? Using the integer division, we could, and let me move it up in case you guys can see it. All right. Using the integer division, I could do 7 divided by 2, get 3, multiply that back times 2, and then subtract it. to see if I get a remainder. But that's like 2 or 3 steps. Still could do it, but that's some extra steps. It's kind of unnecessary, right? This guy, I usually do the mod, be done with it. So if I wanted to see if 7 was even, I could do 7 mod 2 equals, see if I get 0. Because as you guys told me, it should be 0. The module should be 0. It should have a remainder of 0 if it's even. So if I were to do that, it gives me false because it's not even. That makes sense. So I wanted to check to see if this was evenly divisible. What I could do is I could actually test it. I could say, is the num mod 2 equal to 0? Okay. Now, if I want to tell the user that their number is even, I'll have to print that, right? Okay, so print your number is even. But I probably want to tell them, I probably want to tell them that it's not as well, right? If it's not working. Your number, maybe I'll even go as far as to say your number is odd. Okay. Well, I only wanted to tell them it's even if it's even. I only want to tell them it's odd if it's not even. So the way that what we've learned so far is I would have to create 2 different files, right, in order to tell it that it's even or not. So this first one, they plug it in here and they could test and then get a result, right? And if it was if this was true, then they could print this out. Then they go to the other one to test and it would print out that it was odd. That seems like a lot of work, right? To go through 2 different files to do so. So what if there was an easier way to do that? And there actually is. I actually kind of said it. So in Python and in most languages, you can do something that's known as a conditional statement. You all may have learned about conditional statements when you learned about truth tables or anything like that when you were in like middle school, I believe was part of the curriculum. I know at some point in time, Arizona took it out of their curriculum. But pretty much the way it works is you say if this thing, then this would be a part of it. I know you guys saw this in the workflow video. Well, if there's an if, then you usually have some kind of way to say otherwise, right? Or else. And that's where this will come into play. So if this, else this. So if when you divide by 2, you get a remainder of 0, it's even. Otherwise, or else, it's not. I'm gonna run that real quick. I get my no, that's correct. What is it bad at? Let's see. Bad at. No, that is right. You're mad at me. All right. Well, I am not sure why it is mad at me right now, but Python is mad. I think it was all those enters I put in at the end there. It's not liking the syntax here, even though it's good to go. So, but anyway, it's 8:30. So we'll look more at this next week. If you want to go for doing this into your temperature conversion project, you can. You can use an if statement. I will allow it. If you want to do 2 files, that's fine too, because that's the assignment, to do 2 different files. If you want to do the 2 files and then give it a try, there's no harm in trying, right? And it'll help you grow in understanding with programming. But all right, that's it. You all can stay behind if you have any additional questions. But I will see you guys on, next Monday is Labor Day. So technically we're not allowed to have class. I will be on here. If anyone wants to join, you can. It is not obligation. However, I will be in here and I will go over some things and record that. And so if someone is here, they'll probably allow me to give and take a lot better, questions and things like that. So if you want to come next Monday, you can. It is a holiday. It is not mandatory. You guys will be able to watch the video that I have afterwards, though. Okay? So that being said, I'm going to stop recording now.